welcome back, everybody. Okay, Alexis, how you feeling? You feeling a little bit more awake this period? You give me the peace sign? All right, cool. Yeah, a little bit. Okay, cool. Excellent. So here's what we're gonna do. Let's start off the period by opening up our ratios and proportions day 2, the guided and modeled instruction, okay? You have your own copy of the slides. I have my copy of the slides. So what we'll do is as we go through them, I'll give you a chance to stop, transition over to your slides and update them. That way you have your own notes. They're in your own words. You can synthesize them in a way that makes sense for you. And we'll just continue this way. We'll go through the slides and review what we learned last period, right? We will then work on a couple of practice problems together. We'll close out by reminding and refreshing what we learned. And then what we'll do is I'll release you for another exit ticket. Now I looked at the scores on the exit ticket from 4th period from earlier this morning, and most of you guys just beat the tar out of it. I couldn't believe how well you did. How many of you guys feel like you're gonna have to go through and watch that reteach video that I linked for you?
I already did that.
You already did that, excellent. So that was Gabriella, right? And Gabriella, did the reteach video kind of shore up some of the confusion about what ratios are and how we write them and kind of what their purpose is?
Yeah.
Okay, good. So if you're still lost, don't worry about it, sweetheart, because we're going to spend this whole period getting you back on track, okay? Like I said, this is day 1. And unfortunately, I've had to kind of consolidate days 1 and 2 into 1 or 2 lessons, just because logistically speaking, our time is so limited, okay? So let's just jump right into it. Here's what you're gonna need to be successful this period. You need that whiteboard, that dry erase pen and your eraser, obviously your Chromebook, your pencil, and get a scratch paper for cubes. We're gonna use our close reading strategy for math today. We call that cubes. So get all those together if you haven't already. You should have them close at hand. If you don't, I'll give you about 10 seconds to get that together while we go over our expectations. Expectation number 1, Shayra, what's my first expectation, first and foremost, always?
To listen and follow directions.
Listen and follow directions, excellent. What's my second expectation, second and I guess foremost? Jesse, what would be my second expectation always?
Actively listen and participate in the listening.
Very good. My third one, let's go with Isaac. What's my third expectation, Isaac?
Cameras on and mics muted.
Good. And look, listen, if you're in a position where you're at home, mom's getting ready for work, or you got little monkey brother and sister running around behind you, don't worry about your camera. I know what your face is. I know what you look like. If it's not a good time for you to have a camera on, you guys know that I'm pretty lenient with that. You guys are usually really good about keeping your mics on and your cameras muted. Cameras on, mics muted. Gabriella, give me my 4th expectation, please.
Practice effective and efficient collaborations, no sidebar conversations.
Right. So that means, look, if your cousin's over for the day and trying to talk to you, just kind of give them this is the thing my wife does, right? When she's on a business call, and I'm like, hey, honey, what are we doing for dinner? She gives me the one finger, right? The one finger up that just tells me, wait a minute, okay? And at all times, what is my final expectation? Karen Salguero, what is my final expectation?
Soar at all times.
Soar at all times, right? Show ourselves the respect that we deserve by taking our education seriously. Let's tackle the task at hand by being on task. Let's develop those responsible study habits, and let's reach for personal best so that when we come back in January, as Kevin and I were just discussing, we're not drowning, right? Let's just make sure that we're all developing those responsible and healthy study habits. All right, so our lesson objectives, what are we gonna be able to do today? Primary objective, let's go with Mr. McMahon. Can you read me this primary objective? What are we gonna be able to do by the end of this lesson or series of lessons?
Ratio to describe the relationship between two
You got it, come on.
quantities.
Quantities, right? Very good. We're going to learn how to write a ratio to describe the relationship between 2 quantities. Francisco, what is a quantity? If I use the word quantity, what am I really saying, Francisco?
An amount.
Yeah, an amount. How much I have of something. Like if I turn around and look behind me, the quantity of guitars in this room is 9. There are 9 guitars in this room. way too many guitars for one room, if you want my wife's opinion, right? So our secondary objective, we need to remember that there are 3 different ways that we can write ratios or notate them, right? If we're using our academic mathematical vocabulary, there are 3 different ways that we can write or notate these things. Jesse, what's the first way that sticks out to you? What do you remember from last period? What's one way to write a ratio?
Colon.
A colon, right? We can use a colon. Remember I told you that my kid from last year, he called it that ... Every time I would ask him, how do we write a ratio? He'd say, use that ... Now, we don't want to use that ... as our phrase. We want to call it a colon so that we're using the proper academic vocabulary. Let's go ahead. What's the second way that we can notate ratios or write them out? Alexander, what's the second way that we could, so we've got the colon, that's number 1.
Fraction mark.
We can use a fraction bar, exactly, right? We remember that if fractions and ratios, that there's a good amount of crossover territory, right? That fractions and ratios tend to look, act, and sound like fractions, right? So that's the second way. What's the third way? So we've got colon, we've got fraction bar, and what's the third way? Natalie, what's the third way that we can notate or write out ratios? If anybody wants to jump in and help her out, you're more than welcome to. Let's check the chat log, see if
Two.
Yeah, exactly, Natalie. Thank you. Sorry, I didn't realize you were muted. Yeah, we can use the word two. So we can say things like 9 guitars to 2 keyboards, right? Or 9 guitars to 1 drum set. We can use the words to, we can use a colon or a fraction bar to write these out. Very good. I'm glad that stuck with you guys last period. So doesn't look to me like we need to spend a whole lot of time in the kind of the meat and potatoes of reviewing. It sounds like you guys had this stuck. However, we do need to spend a little bit of time reminding ourselves. There are also, so there's 3 ways of notating or writing ratios, but there's also 3 different kinds of ratios. Do we remember what they're called? Let's go with Krishma. What's one kind of ratio that I can make? And we're on slide number 9.
You can make is using 2.
Okay, yeah, that's the notation. Let me be more specific. If I have a quant or 2 quantities of something, I can compare not only the parts to each other, right? We call that a part-to-part ratio. And that's where if I were to say something like, if I have a pencil box full of pencils and markers, let's say I have 3 pencils and 5 markers, I can compare pencils to markers. I can say 3 to 5, right? I can also flip it and say 5 to 3. But what's the other kind of ratio that I can make? Instead of, look, Shayra, you're on it in the chat log. Shayra writes, we can render part-to-part ratios, we can render part-to-whole ratios, or whole-to-part ratios. Very good. And what's another word for whole? I know that can be kind of confusing. What's a synonym for the word whole? Go ahead, Alexis. Let me rephrase it for you, Alexis. If I say I want to know the whole amount of something, what's another word for whole?
The equal amount of it.
Okay, maybe equal. Sure. Valeria, what do you think?
Total amount.
Total, right? And so these are going to be those signal words that kind of tip you off on what kind of ratio you need to make, right? I'm sure that you noticed in your exit ticket from last period, we have to be sure that we're organizing our ratios in the proper order, right? So if somebody says, I need to compare the amount of pencils to markers, we need to make sure that the quantity of pencils comes first in our ratio, okay? And if you're ever confused, or if you ever need a refresher, you can always lean on this cheat sheet that I provided for you on slide number 10, right? This little chart here. We have what it looks like to notate and write out part-to-part ratios. We've also got, we also see that there are ways of writing out part-to-whole and ways of writing out part-to-part. We also know, so in addition to all of that, 3 notations and 3 types of ratios, we also know that there are some other signal words that will tip us off that we're working with ratios and proportional relationship style problems. What are some of those words or phrases that we can kind of be on the lookout for when we're solving complex word problems? What do you guys see at the bottom of that page there?
Also use the phrases for each and for every.
We can use the
to
phrase.
describe-
That's right. We can use the phrases for each and for every. So remember back on last period when we looked at the difference between the price of yogurt and the price of sandwiches. And every time we bought one more yogurt, our price increased by $3. We all remember this, yes? And what that means is that for every one yogurt, we spend $3. Or for every one sandwich, we spend $6, right? So we just need to keep those phrases kind of at the forefront of our minds. Now, let's get into some guided practice. And this is where you're gonna kind of have a chance to test drive this new skill off the lot, okay? This is where I'll help you guys and walk you through it. Let's look at a few different kinds of problems and figure out how we can solve them. So, we need to remember that how we read problems concerning ratios is gonna determine how we have to solve them, right? So let's look at this one right here. Let's have one of my strong readers. Can I have a volunteer to read the problem? It's on slide number 12. Let's go with Karen. Can you read me the problem here at the top of slide 12?
Chris mixes 4 cups of cereal, 3 cups of pecans, and 2 cups of raisins to make a snack mix. How can you use ratios to compare quantities of each ingredient and the total amount of snack mix?
Very good. So let's read that problem. We did. And let's consider what close reading strategy do we usually lean on for problems that look like this? Because this doesn't look like a straightforward algorithmic problem. This is what we call a word problem. It looks like a paragraph. What do we use to unpack and analyze word problems? Cubes. So let's go ahead and take a minute. I'm going to stop sharing my screen and I'll share my document camera with you so that we can work through cubes. And again, you can pull up slide 12 in your own slideshow to keep the numbers and all the information straight for yourselves. I'm going to go ahead and spotlight my camera so that you guys are able to see. If I can find my camera, there we go. Spotlight for everybody. Is everybody able to see this nice and big and clear? Good. Thank you for the thumbs up, Kev. All right, so let's start with C. Let's circle and rewrite important numbers. What are my important numbers in this problem?
4, 3, and 2.
4, 3, and 2. And let's make sure that we keep, since we know we're dealing with different ingredients, let's keep them straight as we cubes. So we have 4 cups of what? Cereal, right? So let's go ahead and make sure that we reflect that in our cubes annotation page so that we're not getting our quantities mixed up and tangled in each other. What is how many cups of pecans do we have?
3 cups.
Okay, so 3 cups pecan. Very good. And let's take a look at raisins. How many cups of raisins do we have?
2.
2 cups of raisins, right? So 2 raisins. Let's go ahead now and underline and rewrite what task it is that we need to accomplish for this question so that we don't get lost. Remember, this is the grocery list analogy. We don't want to just wander around the grocery store. We need to know exactly what we're looking for and about how much we need to spend, right? So, Valeria, you're usually really good at kind of parsing out and picking through the problem to find the task. What is it that we need to do? So I'm going to write this out in an affirmative sentence. I need to do what?
I need to find how can you use ratios to compare quantities of each ingredient.
Yeah.
And the amount of snack mix.
Exactly. So I need to compare quantities of ingredients, right? And we could shorten it to that. You definitely got down to what is being asked of us, but we can go ahead and truncate or abbreviate. So I need to compare quantities of ingredients. Yeah, very good. Okay, well, let's go ahead and box signal words. Let's look at some signal words that are directing our traffic, right? This is going to direct our thinking. This is going to show us which way we need to be moving. Does anyone see any kind of signal words? Camilla says, I can't see much. Oh, yeah, I can definitely zoom in. Thanks, guys, for keeping me. There we go. Is that better? Camilla, is that better for you?
Yeah.
Okay, cool. Thanks, Kev. All right, so Karen,
Thank you.
yes, you're very welcome. So Karen says that she sees the words total amount. And what did we talk about? When we see words or phrases like total amount, we know that this is going to be a ratio problem, right? It can also be a problem that deals with addition or multiplication, but for the purposes of our lesson today, we know that this means we're going to be setting up a ratio. So how can we make ratios that compare the ingredients to the total amount? So this is going to be what we call a part to, and what's another word for total amount? What's that word that starts with a W?
Whole.
Yes, this is a part to whole ratio. We're going to be making part to whole ratios here. Good. Now we can eliminate all of that extraneous stuff that we don't need, all that extra stuff that we have no use for. We don't care that this kid's name's Chris, right? We don't care that this is snack mix. And instead what we can do is break down the problem to kind of its most bare and fundamental pieces. So one way that we can kind of visualize this problem, and many of you guys are like me, to where when we get into the habit of using, when we use models and graphs and stuff, my brain just doesn't think when I'm doing math, my brain doesn't work visually very well. But one way we can visualize this is to use a model, right? And so what is it that we see represented here? How are we representing the the amount of cereal? What is it that you see here that's representing the cereal, the quantity of cereal we have?
We're seeing 4 cups with cereal.
Literally 4 cups, right? Okay, so let's take that even further. How are we visualizing the pecans in this problem? What do we see here that represents the number of pecans?
3 cups.
3 cups, and we see 2 cups of raisins. Now, let me ask you this question. How would I find the total amount? If I have 4 cups of cereal, 3 cups of pecans, and 2 cups of raisins, how is it that I would find the total number? What would I do? Meaning the total quantity of ingredients that I need. What would I do?
Count all the cups of cereal, pecans, and raisins.
Cereal, pecans, and raisins, right? I would find the total amount of all of these ingredients combined. And another way that we can visualize this is with what we call a tape model. So take a look at this tape model and look at how, instead of using pictures of literal cups, we can visualize each cup of each ingredient using bars, right? We can call this a bar model or a tape model, okay? And again, this is all kind of a matter of preference. You may find that visualizing this just by writing the numbers in your cubes annotation is the best way for you to visualize this. You may also understand that a tape model may be a good visual representation for you. And what I like about the tape models as opposed to the actual drawing of 4 cups is notice what it has down here at the bottom. Instead of just giving us cereal, pecans, and raisins, it also gives us a fourth category of the running total. And so let's go ahead and find what is the total amount of ingredients that I have if I combine cereal, pecans, and raisins. I see 1, 2, 3, 4, 5, 6, 7, 8, and 9 cups total. So we need to remember that we can use ratios to compare quantities. We can use these comparisons to compare part to part to whole, and whole to part. In this problem, let's remember, what kind of comparison are we making? Are we making a part to part, a part to whole, or a whole to part? What do you guys think, based on your cubes annotation page, what kind of ratio are we going to be writing?
Part to whole.
Part to whole, very good. I admire you guys. That right there in a normal classroom setting would take about 2 days to kind of drill into a student. You guys are just the best. So, what are 3 ways that we can write the ratio of cups of cereal to cups of pecans? Well, let's take a look here. And you guys will notice that you can manipulate your own slides. You have access to edit your own, but you are more than welcome to follow along with me if that is what you choose to do. So, what are 3 ways that we can write ratios of cups of cereal to pecans? Well, how many cups of cereal do I have?
4.
Okay, so I can start by writing 4. Now, how many cups of pecans do I have?
3.
3. Okay, good. So here's the deal. What are the 3 ways that I can notate this? 4 to 3. Well, I know I can use the word to. I know that I can use a colon, so I can say 4 colon 3, or I can say 4 fraction bar 3, right? 4 over 3. Okay. Well, let me ask you this. We know that the actual question that was being asked of us when we looked at it was a part to whole, but when we compare cereal to pecans, is that a part to whole or is that a part to part? What do you guys think? Yes, Jesse, it is a part to part. So we can say it is a part to part comparison. Exactly. Let me go ahead and fix that so that you can read it. There we go. All right. Well, what is the total amount of snack mix? Shayra, what's my total combined quantity of ingredients? Yes, so I have 9 cups total. Very good. You guys are beating this up. All right, so now let's write ratios to compare the amount of each ingredient to the total number of snack mix. Okay, so let's start with each ingredient. Let's compare cereal to total. Well, again, how much cereal do I have? How many cups?
4.
4, and how many total do I have?
9.
Okay, so we can write 4 to 9. Let's go ahead and move on to pecans, however you pronounce it. My mom calls them pecans. How would I compare pecans to total? 3. Finish that thought, Jess.
9.
3 to 9, right? Exactly. 3 to 9. And let's go ahead and do raisins. Let's go with Kevin. How would I compare raisins to total?
How can you compare raisins?
Yeah, how would I compare raisins to total, Kev?
Raisins 2 to 9.
Excellent. Well said. 2 to 9. Exactly. All right. So let's use our academic vocabulary to write out and explain. How can we write a ratio to compare 2 different quantities? Well, I can use a colon. I can use the word to. Or I can use a fraction bar. And again, you guys remember I told you the first couple days of ratios and proportions, they're pretty straightforward. This is basically look at 2 quantities, count the amount and compare them. Once we get into things like ratio or unit rate, when we get into using rate to solve problems, when we get into things like percent, it's going to get way more rigorous. So for those of you that are like groaning and yawning because this is too easy, I'm begging you, hang in there because it's going to be worth your while. We have an assignment later in this unit where we design a trip to Disneyland together. There's a couple other things where we can make a recipe for pozole together using ratios and proportions. So there are some real fun practical uses for ratios. Mr. Juarez, what do you got to say? Go ahead. Okay, you all right?
Yeah.
Okay, so Karen has a good question. Karen says, so how do I know if it's part to part or whole to part? Part to whole and whole to part. So, Karen, here's how we would think of this. We know that cereal, pecans, and raisins, that these are all part of the recipe, right? That these are all kind of, if we were looking at this like how we were looking at least common multiple and greatest common factor, these would be what we call factors, right? They're the smaller pieces that make up the total. So when we're comparing one ingredient to the total amount, that's a part to whole. But if I were to compare cereal and pecans, I'm comparing 2 of these smaller pieces, or what we would call parts, right? So that's the difference between a part to part and a part to whole. And again, by the time we're done with this, you'll be so nauseatingly familiar with this, Karen, that you'll be right as rain, I promise. So let's look at 2 practice problems before we close out. Yeah, you want me to go back? Go ahead, Kev. Go ahead and catch up on your notes. Does everybody need like a good minute or 2 to catch up on their notes? I'm seeing nodding heads and I'm seeing thumbs up. Okay, that's good. Take a minute and a half to get your notes up to date. Okay, I've got the cubes annotation here in the window, and then I'm sharing my screen too so that you can update your math notes. Okay, for those of you who are ready to move on, go on to slide 19 and start to read questions 7 and 8 and see if you can kind of start to answer them on your own so that we can facilitate a more meaningful discussion when we get there. Okay, so take 2 minutes. Go ahead, guys. Go ahead, Valeria. Yeah, if you need to get yourself a glass of water, go right for it.
Okay, I'm done.
Good, Kevin's done. If you are finished and ready to move on, can I get a thumbs up in the camera, please? Get a nice thumbs up. Karen's good, Kevin's good, Shayra's good. Alex is good, Camilla's good, Gabriella's good, Destiny's good, Genesis is good, Desire is good, Natalie is good. Cool, so most of you are ready to go. I'll give it, good, Jeremiah, thank you. I'll give you guys another about 15 to 20 seconds before we move on, just so that everything stays nice and equitable and fair. Okay? All right, good. So, slide 19, here we go. Let's look at how we can apply this to additional problems. Let's go with, can I have Jesse, can you read me question 7 nice and loud, please?
Okay. Leo blew up 7 balloons. Kathy blew up 5 balloons. Write each ratio in at least 2 different ways.
Okay, so let's go ahead and do that. So we know that there are 3 different ways that we can write ratios. We're gonna pick our favorite 2. And I don't care if you do 2 different ones from how I do it. You can do all 3 if you really wanna go above and beyond. So let's think about this. The ratio of Kathy's to Leo's. So remember that the order matters. Remember that the way that we write this matters based on what we're being asked. So we're being asked to look at the ratio of how much Kathy has blown up compared with Leo. So how many did Kathy blow up?
5.
Okay, so we start with 5. Okay, and how many did Leo blow up?
7.
Okay, 5, we can say 5 to 7. What's another way that we could write this ratio out? 5:7, very good. And let's just go ahead for good measure and for good practice. What's the last way that we can write this out?
5/7.
5/7, right? Or 5 fraction bar 7, right? All right, now let's take a look at the next one. Let's write the ratio of Leo's balloons to Kathy's balloons. Okay, write the ratio of Leo's balloons to Kathy's balloons. Okay, so now where do we want to start? We want to start with Leo, since that's what's being asked of us. Well, how many balloons did Leo blow up?
7.
Okay, so now we know we can say 7 to 5. We can say 7:5, or 7 fraction bar 5. Ooh, I wrote 6 and I didn't mean to. Good. Now, for the real test. So Karen, you had that question earlier. And I'm gonna go ahead and annotate my page real quick. You don't have to do this, guys. I'm just gonna draw attention. These 2 that we just did, Karen, these are what we would call part to part, right? Because we're comparing the amount Kathy blew up to the amount Leo blew up and vice versa. But now we're being asked to do something different. Now we're being asked to compare the ratio of total balloons to Leo's balloons specifically. So what is the total amount of balloons? How can we find the total here, guys?
Adding 5 and 7.
We can say what? One more time. You said it, but I didn't catch it. I'm seeing stuff in the
You
chat.
can find the whole by adding 5.
Yes, yes. We can find the whole by adding 5 and 7. So what is 5 plus 7? 12, right? So we're going to compare the total amount, which is 12, to Leo's specifically. And how many did Leo blow up?
7.
7, right? So we can say 12 to 7. We can say 12:7. Or we can say 12/7 or 12 fraction bar 7, right? And again, in Google Slides, it doesn't format fraction bars very nicely. So you can use that slash mark to represent that. So great. Let's go ahead and move on to question 8 together. And then what I'm going to do is I'm going to release you to do your exit ticket. And it looks like we may have a good amount of time left over, like I had budgeted for. So what we'll do is I'll give you a few minutes to do your exit ticket. We'll kind of analyze the results. I'll take a look at who got it and who didn't. And then I'll let you watch a video about our student store so that you guys can see what kind of awesome incentives are waiting for you when we come back. Okay, so let's look at question 8. Each class has the goal of selling 100 tickets to the school carnival. Ms. Garcia's class sells 87 tickets. Mr. Carpenter's class sells 113 tickets. Write each ratio in at least 2 different ways. So we're just doing exactly what we practiced before. Let's start with Garcia to the total goal. Okay, well, how much did Miss Garcia sell?
87 tickets.
87. And what is our goal? What is the goal that is outlined in the beginning of this problem?
100.
Right. So let's go ahead and say, we can say 87 to 100. We can say 87 colon 100. Or we can say 87 over 100, right? Very good. Now, let's do the ratio of Mr. Carpenter's sales to the goal. All right, well, how much did Carpenter sell?
113.
Okay, so Valeria, while I've got you on the line, how would I write this out as a ratio comparing Carpenter's to the goal? We could say 113
113 to 100.
to 100. What's another way, Valeria? Give me the other 2 ways.
113 colon 100.
113 colon 100. And finally, what's the last way?
And 113 fraction bar 100.
Good. So let's think about this logically. Which class met the goal or exceeded the goal? Did Garcia's class get to the goal or no?
No.
Nope. They only got to 87. But Mr. Carpenter's class, did they meet their goal or did they exceed their goal?
They exceeded.
Right. They blew right past it. They did 13 more than they needed to. So final one, the ratio of Carpenter's to Garcia's. And this should be pretty easy. So let's go ahead and Carpenter to Garcia. How many did Carpenter's class sell?
113.
113. And we can use the word 2. And how much did Garcia sell?
87.
Good, very good. All right, so we can use the word 2. We can use 113 colon 87. We can also say 113 over 87. Very good, you guys. So listen, if you understand this, your exit ticket's gonna be a walk in the park. It's just gonna, you guys are gonna look at it and you're gonna laugh. So you can find your exit ticket linked on slide 22. You'll see the blue link there. If you click it, it'll open right up for you. Let's go over the question set so we know what's being asked. In your own words, define what a ratio is. You can make sure that you frame your answer this way. A ratio is and I gave you blank spaces here, is a way of doing something. That's how I want you to frame this. A ratio is a way of doing something. Now you can go back to use the slides to get yourself unstuck if you're stuck, but by now you should be able to answer this question. The second question is, Mr. Stockman has 4 black pens and 2 blue pens. He writes the following ratio, 6 to 4. What kind of ratio has he just written? Is it a part to part? Is it a part to whole? Or is it a whole to part? Okay, so that's the second question. The third question, select all the possible notations for expressing ratios. This one should be very easy. Okay, we can use colon, fraction, a period, using the word and, or using the phrase is greater than, or is it that we can use the word to? Okay, so click all that apply there. And then the fourth one is about our good buddy, Mr. Zandis, who you haven't had the pleasure of meeting yet, but usually he'll ambush our classroom pretty regularly. Mr. Zandis wants to write a ratio that compares the number of girls to the number of boys in his classroom. He currently has 16 girls and 17 boys. He writes the following ratio, 17 over 16. Is he correct? Why or why not? So I'm going to ask that you do this exit ticket quietly. We're going to analyze the answers together, and then we can watch a quick video about the awesome incentives that our administration and our leadership team have set up for you guys this year. Okay? So take a few minutes to get this done. It shouldn't be too much, and we will touch base as soon as I get the results.